Hello, I'm Benjamin Bradshaw. I'm a computational science PhD at San Diego State University. I have a background in mathematics and physics, and I'm going to present today on reconfigurable intelligent surfaces. This is a state-of-the-art study on reconfigurable intelligent surfaces. I'll refer to them as RAS more often than not. Understanding the possibilities and capabilities of these RAS systems, like what they do, how they do it, and how to design one. Specifically, what is an RAS? RAS systems are reflective surfaces that can control their reflective properties to be optimal, to create optimal paths from base stations to users. Specifically, if you look at the figure on the right, a reconfigurable intelligent surface can be one that is used to reflect around obstacles. These are important to reduce losses, especially for 5 and 6G communications, as these are inherently lossy and will not be able to, 6G will not be able to be implemented without being able to reduce the losses. So we also want to understand the possibilities and capabilities and explore future directions for research in our lab. So there are a couple of different implementation of reconfigurable intelligent surfaces. The first one is through reflect arrays, which are arrays of a bunch of smaller antenna elements. This is an old technology, so it's well researched and well defined, but some of the limitations are the spacing, as these are required to be fairly large to implement reconfigurable intelligent surfaces. Metasurfaces are a new technology that doesn't have the same limitation of being quite as massive, but these are more difficult to design, and each of the elements are small resonator elements. So talking about anomalous reflection and controlling reflective abilities, we have to talk about the law of reflection and refraction. Generally, the normal law of reflection is violated in these systems, but that's because we have to look at the generalized versions of these laws. Specifically, our reflection can be controlled through controlling the different phase of the reflective elements themselves, so the reflective phase of each of our resonators or antenna elements, as governed by these different equations here and as shown on these graphs. To summarize what I've gone over, this is a state-of-the-art study of reconfigurable intelligent surfaces. It defines the purposes and capabilities of reconfigurable intelligent surfaces, and it covers different implementations by metasurfaces or reflect arrays. The study also reviews the physics behind the design for anomalous reflections and how this controls the surface of each element. Thank you for listening. I would love to discuss more details at the ACSESS event on April 7th if you come to my poster presentation.